Hello and good evening my all dear student. I hope you all are doing good. So let me just quickly check from my end that whether my voice is audible and I'm clearly visible to all of you. Just quickly let me know that my voice is clear to all of you. Give me a thumbs up in the chat box so that we can start today's class. Alright, so I'm checking from my side. You also comment that whether my voice is clear or not, if it is audible or not to all of you. Just give me a quick thumbs up. Okay, from my side voice is good to go. I can see that. You all can give me a thumbs up from your side that yes ma'am, your voice is audible. So I'm clearly visible as well. A very good evening to all of you. I hope you all are studying really well and revising all the lecture, because in upcoming days your half yearly exam is going to happen. So whosoever having their half yearly examination in upcoming days, so you guys have to be very cautious that how to study, how to manage your time. Also revise all the lecture and the most important question that we have discussed in the lectures only. So during the lecture I have mentioned about many questions. We have solved many questions during the lecture as well, and at the end of the chapter we have discussed few questions that are frequently asked in your examination, right? So all of you need to be little, now have to do little hard work, not little, much hard work, so that you can score good in your half yearly examination, because only 2 chapters are coming. First chapter we have already completed and the second chapter we will be completing till the next lecture, right? So all the chapter has been completed. The chemistry syllabus will be completed by the next week. So you all have to stay updated with all the subject, because other teachers are also completing your syllabus. So complete your syllabus, revise it, practice the question, and if you will do these 3 things, trust me student, nobody will stop you scoring good in your examination. So I hope you all are ready, you all are studying very hard. So let's move on to our chapter. So we are studying more about the matter around us pure. So in the previous lecture we have discussed about the classification of matter on the basis of their chemical property. So according to the chemical property, according to the chemical behavior, matter is divided into 2 classes, which is pure and impure, right? Also we have seen the further classification of pure substances into elements and compounds. Also we have again further classified the elements into 3 categories, which was metal, non-metal and metalloids, and we have seen the properties of all of them, right? And we thoroughly understand the topic. And on the other hand we have studied the compound, that what are compound, what property they have, and lastly we have discussed about the impure substances, which is like mixture, right? So impure substances are also known as mixture, and we have studied that what are mixture, what are the category of mixture, but the detailed discussion was remaining. So today we are going to understand what are mixture, how we are going to classify the mixture into different class, and what are the use, what are the daily mixture that we have seen in our real life. So that all this chapter covers. So I hope from our end we are good to go. Now I am starting the class. Okay class, so in the last lecture we have discussed the properties of the pure substances, and in today's lecture we will be focusing on the properties and the type of mixture. So as we have discussed earlier that what are the mixtures. Mixture are made up of 2 or more substances in any proportion and not chemically bond with each other, right? So mixture is formed by the composition of 2 or more substances in any proportion. Also they are not chemically bonded, and they can be physically separated. They can be separated into their constituent by the physical method. So these are the few properties of mixture. Now let's just understand them in detail. If you take this container, so let's just take this container. In this container I have put sulfur and I have put some pieces of iron. So these dark pieces are for iron, okay. So in this container we have added sulfur and iron. Now this is a mixture because they are not chemically combining with each other and they are not in a fixed proportion. here. So can we separate them like this? Yes, we can. So we will use the magnet, and we know that the iron substances feel magnetic force when we'll keep the magnet near to them. So with the help of magnet we can separate the pieces of iron from the mixture, and hence you can see all the pieces of magnet will of the iron will get separated. So from here we can say that the mixture can be further subdivided into simpler substances by simple physical process like holding a magnet, hand picking, weaving, or evaporation. These are the physical method by which you can separate the substances into its constituent. So mixture are the substances which can easily be further subdivided into simpler constituent. But on the other hand, compound or the pure substances was not like that. We cannot further divide them into similar substances with the use of physical method or simple physical method. If we want to do so, we have to use the chemical method to separate the constituent. So this is how mixture are different from the pure substance. So the first property is that they can be separated with simple physical methods. Second, the constituent of a mixture retain their original property. So if you mix something, if you mix two or more substances, you will get the essence of all the substances which it is made up of. So it will have the property or retain the original property of the substances. Like if you are making bhel puri, now everyone will be feeling little hungry and mouth watering that bhel puri ma'am is making bhel puri. So in bhel puri we mix many substances, and we get the taste of each of the constituent that we are mixing together, right? We are getting the taste of lemon, we are getting the taste of murmuras, or the sev we are mixing. All the Indoris are now feeling, it's very mouth watering when you heard the name of sev, right? So here, if you mix many, you will get the taste of tomato as well, and whatever you are mixing in it, all the spices that you are mixing in it. So we get the taste of each and every constituent which are mixed in bhel puri, and bhel puri is a mixture of two or more substances. So it retain the original property. Every constituent retain their original property, unlike the compounds, because in the compounds we know that they do not retain the property entirely change because the new substance has been formed. So this is the second property, and you can say the difference from the pure substances, right? Next, in a mixture the constituents are not mixed in a fixed proportion, that we know that we can mix in any proportion. If you are making bhel puri, you can mix any of the substance according to you. Indoris will add more sev, and the non-Indori people will add some other substances, like somebody like sour taste, so they will add more lemon. Somebody likes spicy taste, so they will add more spice into it. So this is how proportion could be anything. It is not fixed. So these are the properties by which we can understand the difference between the mixture and the compound, or you can say the pure substances and impure substances, and they are the separate these are the separate properties of the mixture. So if question will come, so from these three factors you can write two answers. One answer is that if they are separate property of the mixture, you can write here. Also, if in question differentiation will be asked, you can also write with the use of these same property, you can differentiate the mixture with pure substances or mixture with the compound. So two answers can be written from this format, right? Chaliye. So now let's move forward to the categorization of mixture. So as we have discussed it in the earlier class as well, that mixture are categorized into two classes, homogeneous and heterogeneous. So now what is homogeneous? So as the word says, homo means very homely, right? And when something is very homely, we also classify it as similar. So in home we found out similar people, right? Similar culture, similar belief you will see, right? So homo means similar, genus matlab mixture. So when particles mix in such a way that they will look similar, you cannot even differentiate between the particle, that this particle of this substance and this particle of this other substance. So they mix so uniformly that distinguishing between the particle is impossible. They look similar. They mix so uniformly. So that's why a mixture in which component mix uniformly or mix uniformly and they do not have any visible boundaries are known as homogeneous mixture, right? So from here we can define homogeneous mixture. We know that classification of homogeneous and into heterogeneous. So homogeneous mixture, a homogeneous mixture is a mixture in which constituents are uniformly mixed. So you have to keep this word in mind, uniformly. The distribution is uniform. There is no visible boundary. Each and every particle looks similar now. You cannot even differentiate between the particles, right? Example, let's take an example. If you mix any syrup into your water, so this is a mixture of water, sugar and rose syrup, right? Now we have made a sharbat from it, right? So we have made sharbat from these three constituents. Now are you able to distinguish between the particle of sugar or the water or the syrup? Can you see the different particle here and there, so that you can analyze that these are the particle of water, these are the particle of sugar and these are the particle of syrup, right? You cannot differentiate. Why? Because particles are uniformly distributed with each other. They have no visible boundaries by which you can identify, and you can say that this particle belongs to this substance and this particle belongs to this substance. So there is no visible boundary, uniform distribution. That's why these kind of solutions are known as, or these kind of mixture are known as homogeneous mixture. Salt and water, also a homogeneous mixture. And then we say salt and sugar, not salt and sugar, sugar and water. These are all your homogeneous mixture. What is the feature of these mixture? That they have uniform composition, not physically distinguishable, right? You cannot physically distinguish them and separate the particle, right? Let's move on to the heterogeneous type of mixture. So what is hetero word means? Hetero means different. You might have heard this term in your biology classes as well. Hetero means different, genus means mixture. So here you can say that, you can clearly say that when homo means particles are uniformly distributed, here the particles are not uniformly distributed. You can distinguish the particle from very easily. Physically you can distinguish the particles. Also they have visible boundary. You are able to see that which particle present where and which particle present where. So they have visible boundary, non-uniform distribution. So these kind of mixture, or you can say opposite of homogeneous mixture, is known as heterogeneous mixture. So a heterogeneous mixture is a mixture in which the constituents are not uniformly mixed. So there is no uniform composition throughout the mixture, is known as heterogeneous mixture, right? So non-uniform composition they will have and physically distinguishable. And what are the example? You can see the muddy water. So here you can clearly distinguish between the mud particle and the water particle. You can clearly see. And this example, water and oil. So you can see the oil which is present on the surface area and water on the bottom. So we are clearly able to see. So there is a boundary, there is a visible boundary, that above this boundary we have oil and below this boundary we have water. So there is a clear boundary. Even if you add rock pieces into water or you mix sand into water, there as well the sand will accumulate it at the bottom and water will be present upside it, right? So water will be present here like this. So this is a clear boundary, that above this boundary you have water and below this boundary you have sand particles. So when you have seen clear boundaries and there is no uniform distribution, then those type of mixture are known as heterogeneous mixture. I guess it is very clearly understood, or easily you can depict the definition by the name of their by the name of these mixture. We can clearly distinguish between these two type of mixture. So a question can come that differentiate between homogeneous and heterogeneous type of mixture. So first distinguishing that they are uniform, they have uniform composition, but they do not have uniform composition. Here they can physically distinguishable, there they cannot be, right? And then you can write one example and you are good to go. So this is how you can differentiate between these two. Now let's move forward. So we have different type of mixture. You can see here we have bhel puri, marshmallow, then we have mixture of vegetables, few chemicals, and then we have the salt and water solution or the mixture, and this is also a mixture, and KMNO4 mixed in water. So we have different kind of mixture that we can categorize as homogeneous and heterogeneous. So here you can clearly see the different particles, they are not uniformly distributed. So this is what these all the above three diagram represent the heterogeneous type of mixture, where you have clear visible boundaries, you can clearly see the particle, you can physically distinguish between the particle. But the below picture are showing the heterogeneous type of mixture. They are mixture, they are made up of different type of particle, but you are not clearly able to see that what is the visible boundary. There is no visible boundary, they have uniformly distributed with each other. So particles are not physically distinguishable, right? So this is how homogeneous and heterogeneous solution looks like in our daily life. So these are the things that we have seen in our daily life or the labs. So wherever you can see these type of solution, you can distinguish between them as homogeneous and heterogeneous type of solution or the mixture. Right. Now, is there any further classification for these type of mixture? So yes, we have further classification of homogeneous mixture as solution. So homogeneous mixture are further classified as solutions, and heterogeneous mixture are further classified as colloids and suspension. So they are classified as suspensions, and we call other category is colloids, and here homogeneous mixture are known as solutions. So this is the further categorization of these two type of mixture. Alright, let's just understand them one by one. What are homogeneous mixture, or you can say solution? So homogeneous mixture or solution, you can use the term interchangeably. That how does it form? So a solution is a homogeneous mixture of two or more substances. So we know that in a mixture you always going to mix two or more substances, right? So homogeneous mixture, or you can say solution, a solution is a homogeneous mixture of two or more substances like alloys, soda water, sugar and water, okay, salt water. All these are called homogeneous mixture, which means you can say that all of them are solutions. So this is the small definition for solution. Now how to you can see one type of solution. Here you have taken salt in the spoon, and in the flask you have water. Now you are mixing the particle, and after mixing you will get the salt solution, right? So what you have mixed? You have mixed some salt into the water, and when you stir this with the help of any equipment or the help of spoon, you will get the solution. The particle will dissolve uniformly. The sugar particle or the salt particle will dissolve uniformly, and you will get the salt solution. Now the point that we need to observe here, that particles spread uniformly in the solution, right? Particles in a solution are very small in size. Yes. So from here we can say that a solution consists of two components. A solution is equals to two components. What are that we have mixed two type of substances, right? Salt and water. So from there you can say that solution is a mixture, or solution is the culmination of solute plus solvent. So whenever these two combine and mixed uniformly, a solution has been prepared. Like you mixed salt into water. So what does it give you? It gives you salt solution. When they culminate with each other, when they mix well with each other, it will form salt solution, right? So these are the component. This is known as component of the solution. That solution is made up of two type of substances, solute and solvent. In general we call them many substances, two or more substances, but what is the scientific term that we use, or the chemical term we use, is solution is made up of solute and solvent. Now which of the following, like which of the substances are classified as solute and which of the substances classified as solvent? So the substances which are present in small amount, right, like salt. So salt, when you are making salt solution or nimbu pani, right, so what you do, you use many type of substances, but you do not use every substance in the equal amount, right? You will not going to take the same amount of lemon juice that is equals to water, right? You will take more water and less lemon juice, or less sugar, or less salt, and whatever you want to add in it, right? So there will be substances which are always present in lesser amount or in small amount. So they are known as solute. The substances which are present in lesser amount or the substances which are getting dissolved, which are getting mixed between the spaces which is present in the other kind of substances. So like these are the water molecule, and salt will, when you add salt in the solution or the water, the salt particle will get dissolved and take the space. So they are getting dissolved into some substances. So you can define the solute in two ways: the substances which are present in lesser amount or which are getting dissolved into different kind of particle. So from here you can say substances which dissolves, I am erasing all the part, substances which dissolve is known as solute, and the substances which dissolve the solute in it are known as solvent, right? The substance substance in which solute is dissolved is known as your solvent, right? Also you can say that small quantity is equals to solute and the bigger quantity or the larger quantity will indicate the solvent. Now in a solution, how many solvent and solute can be present? Like if you are making a solution, so can two solvent be there or two solute will be there? So the answer is that solute can be any number. Like you can take 2, 3, 4, 5, 10 type of solute. But in a solution, solvent can only be one. Only one, right? That means there will be only one substance which present in the highest amount or in the largest amount, which is going to dissolve the other substances in it. So in a solution there could be only one solvent, but solute can be any number. It could be 1, 2, 3, 4, any number you want to take, right? So this you have to keep in mind, that number of solute can be more than 2, 3, 4, any number, but the number of solvent can be one only. There will be only one substance which is present in the largest amount and which is going to dissolve the other substances in it, right? So this is how you are going to differentiate between solute and solvent. Now types of solution. So these homogeneous mixture are categorized into different classes. Total we have 9 classes. Total type of solution or the type of homogeneous solutions are 9 types, right? And what are they? So if I write that it could be solid type of solution, when a solid substance mixed in a solid substance uniformly, then it is called solid type of mixture. It could be solid in liquid, it could be solid and in gas. So 3 types are these. Then what are more? If you can mix a liquid into liquid, a solid into liquid, or a gas into liquid. Now the other 3 type of solution are these. So 3 are these, 3 are these. Now the other 3s are when you mix a solid into gas, a liquid into a gas, or a gas into gas, right? So we have these 9 type of solutions, homogeneous type of mixture. But we will only going to talk about the important one which are likely to come in your examination. But these are the 9 type of homogeneous mixture that can be possible. So here the state is actually playing a role. Which state you are in? So solid state, when 2 solid substances are mixed uniformly. When one solid and one is liquid substance is mixed uniformly, like salt and water. If you mix salt into water, it is a what kind of mixture? It is a solid into liquid type of mixture. Then solid into gas. So these are the 9 categories of the homogeneous mixture. Let's talk about the important one which will come in your examination. So the first type of solution is solid in solid, right? So the daily life example are alloys. You have seen many alloys around you, even in our jewelries. So you have seen your mother or your sister or your relatives wearing the jewelries, even you also wear few kind of jewelries. So the jewelries are not pure. You must have heard about that it's a 22 carat gold, it's a 18 carat gold, it's 16 carat gold. So why is it so? And you have also heard that 23 carat gold, the pure gold. So the jewelries are impossible to make from the pure gold because it's very brittle, it will break easily. The jewelries it is not possible to make designs from the pure gold, right? So they always mix with some other kind of metal so that the designs can be made. So purity is defined by these carats, right? So what does it indicating? It is indicating that the jewelries that you are wearing are the mixture, are the homogeneous mixture, because if you will wear the jewelry, you will not able to identify which other metal is mixed with the gold. It will only look yellowish in color, right, or the silver in color, or if you are wearing brass jewelry, it will only look brownish in color, right? So you are not able to identify the different particles which it is made up of. But the reality is that it is a mixture of two or more type of element, right? So and we know that most of the element or most of the metal alloys are made up of metal. Alloys is known as the mixture of metal with another metal or metal with few kind of non-metal like carbon, right? So it is a mixture of solid in solid. When you mixing two solid in such a way that they mix uniformly, then that type of solution is known as solid type of solution, or you can say alloys. So brass is a kind of alloy, and these are the example of different type of alloy. I am erasing this part. So you can see that these are the different metal which are mixed with other kind of metal, and what exactly happens here, it will increase the properties of that element. If some metal is very prone to corrosion, it will corrode easily, then you mix the metal with another type of metal so that they will not get corrode. So alloys are made to protect the metal from the corrosion or different type of errors. Also it will give the strength to the metal, right? So why? Because two metal property are combining with each other, so it will become hybrid. So these two metal will contribute their own property to the single type of substance, to the single type of solid and solid mixture. So that's why it will become more strength. They have more strength rather than the individual form, right? So from here you can say that this is the first type of solution, solid in solid, which is known as brass. Now solution of solid in liquid. So when you mixing solids, so these are the common examples: salt in water, that is salt solution; sugar in water, also a homogeneous type of solid and liquid mixture. Here as well a question can come from this: what is tincture of iodine? So tincture of iodine is what? The mixture of iodine into alcohol. Alcohol is also a good solvent. So after water is the universal solvent. It can dissolve most of the thing in it. But after that, if you want to know the other name for solvent, that would be alcohol. So alcohol will when alcohol dissolved iodine in it, it is called as a tincture of iodine. It is used in cough syrups and to get you release with your cough and cold type of situation, right? So this is tincture of iodine mixed with it is a mixture of iodine with alcohol. So this is a homogeneous type of mixture, which is classified as solid into liquid type of mixture. Then we have other categories: liquid in liquid. So when you are mixing two liquid, here acetic acid when mixed with water, so these two are liquids, and you can see they are homogeneously mixed. White vinegar you have seen in your houses, right? Also when alcohol is mixed with water, they both are liquid, and this kind of mixture are known as liquid in liquid type of mixture. Next, gas in liquid. So gas in liquid, another common example which you have seen: oxygen in water. So when oxygen dissolved in water, that is why your aquatic animal are able to breathe, because oxygen is dissolved into the water and they will take the oxygen out of that water. So this is example of gas mixed in a liquid. Also the favorite drinks, the carbonated drinks or aerated drinks that we used to drink our daily life, the Coca-Cola and the Fanta or Sprite. These are the drinks which are the mixture of, you know, some gases into a liquid. So aerated drinks or the carbon dioxide is mixed with these liquids, and that is why you see the fizz on the whenever you open the bottle, right? So these are the example of gas in liquid, right? Next we have gas in gas. Another common example is air that you are breathing right now. So air is a mixture or the homogeneous mixture of many type of gases like nitrogen, oxygen, helium, carbon dioxide, water vapor. These are the gases which are present in your air. So it is a mixture of all of them, and you cannot differentiate that these are the oxygen particle, okay, these are the carbon dioxide particle, these are the helium particle. No, you are not able to see them, you are not able to differentiate. So they uniformly mix with each other in any proportion. That's why they are called as homogeneous type of mixture, or we can say that solution of gas into gas. So when two or more gases are mixed uniformly with each other, they are known as gas in gas type of solution, right? So another example for the gas. So these are the 5. So out of 9 we have studied the 5 type of homogeneous mixture which are important. So most of the question will come from these examples or these type of mixtures. So you have to be very cautious about it. You need to write it somewhere that these are the different type of homogeneous solution. Now let's move forward with the properties of solution. Now how we are going to define the properties? Like we have studied the properties of mixture, we also need to study the properties of solution. So the first property, if I say how we are going to classify them on the basis of their size, the particle size. So they are mixed uniformly and they are not clearly, we cannot see the particles. They are so small that they mixed uniformly and we are not able to distinguish between the particle. Why? Because the size is very small. It is approximately 1 nanometer. If you will write it in the meter, it will be 10 raised to the power 9 meter. So in meter you can see how small this number is. So 1 nanometer is a very small size. So the particle size is very small. Second, physically undistinguishable. You cannot distinguish between the particle. If you mix sugar and water with each other, you are not able to distinguish between the sugar particle and the water particle. Also stable solution, because the distribution is uniform. The particles are uniformly, they are present everywhere uniformly, right? So that's why the particle which are distribute uniformly are also known as, and the type of solution in which the particle are distribute uniformly are known as stable solution. And on the other hand, the solution in which particle are not uniformly distributed, if they accumulated at one place, if all the particles are accumulated at the bottom, then these type of solution are known as unstable solution. So stable solution means they are uniformly, particles are uniformly distributed. Next, they are homogeneous mixture. We know that solution are homogeneous mixture. Then particles are evenly distributed, and that's why they are known as true solution. So solution also sometimes known as true solution because particles are uniformly distributed. Then they cannot be separated by filtration process. Like if you want to separate sugar from the water that you have mixed, now by using the filter paper, like you have taken a filter paper and pour the solution on the filter paper, you will see that all the solution will come out of the filter paper and the sugar or water will not get separated by this physical method. So filtration is a physical method, right? So they cannot be separated by these type of filtration process or the separating techniques. For them you need to use evaporation, because if you will apply evaporation, all the water will get evaporated and sugar will remain in the flask, right? So from here we can say that here they have applied filter paper and pour the solution from it, and then they get the whole solution here. So no residue is settling up here. They find no residue here. This indicates that filtration does not work here. So they cannot be separated by the filtration method. Then they do not scatter the beam of light and the light path is not visible. So they do not. So this clearly says that they are not showing Tyndall effect. We will explain this effect further in the class, but when a light beam passing through the solution and the light path is not visible, that means these particles and these solution do not show Tyndall effect. We will study the Tyndall effect later on. So here you can see that if you pass the light, so from this source, light source, I am passing the light. Now the path of light is not visible within the solution. You can see the light here, you can see the light here, but not into the solution. So the path of light is not visible, so they do not show Tyndall effect. Why? Because particles are so small, very small. Scattering of light will only take place when the particle size lies between a certain range. If the particles are smaller than that range, they will not scatter the light, right? So to scatter the light, the particle should remain in certain range. The particle size should be in a particular range. They should be enough big. Here they are very, very small. So they are not enough big to scatter the light. That's why they are not showing the Tyndall effect. So these are the properties of solution that you have to keep in mind. So a question can come from these property, that write 2 property or the 3 property of the solutions. So these are the property. Even also there is one hot question that can be asked in your examination, that differentiate between the properties of solution, colloids and suspension. So you have to differentiate these type of mixture. So these are the further categorization of the mixture, heterogeneous and homogeneous. So you have to distinguish between these 3 type of mixtures. So solution, colloids and suspension. So on the basis of these property only you will going to differentiate between 3 of them, right? So these are the basic property for the solution. Now let's understand the concentration of solution. So I will check your comments and then we will further move forward with the topic of concentration of solution, which is very important because numerical will come from this topic. So before I'll move forward, let me just check that whether you all are okay. Is there any doubt for anyone? You can mention your doubt if you have any. I will reply and will clear with the topic, right? Numerical will come from this topic. Okay, voice is clear, I guess. Hello Siddhi, hello Pishri, and hello Sanju, hello Anita, hello Vijay Lakshmi, hi Pramit. Okay, your doubt is that solid carbon dioxide formula. So it will be CO2 only. Solid carbon dioxide is CO2 in the solid state, right? Which we also call as dry ice. So the formula is not going to change anyway. It's just that in solid form, when carbon dioxide sublimate, it will convert it into solid form. When you lower the temperature and increase the pressure, the carbon dioxide will look like a ice, dry ice. So the ice cubes you have seen, so it will look like that and the formula will remain CO2 only. But the difference is that in this form it is in the solid state. So it will look like a ice only. Alright. Any other doubt if you have? I hope it is clear. Alright. So let's just move forward with the topic concentration of the solution. So how to calculate the concentration of the solution? What do we understand by the concentration? So the concentration depends on the amount of solute present in a solution. So how we calculate the concentration? The amount of solute which is present in a solution, whole solution. Solution is a mixture of solute and solvent. So there we are calculating the amount of solute, and on that basis we can classify the concentration into 2 categories, or we can classify the solution into 2 class. One is diluted solution. So the diluted solution are those solution in which they have lesser amount of solute. So whenever you will have very less amount of solute, although they are already less, that we have studied that solute are the substances which are present in small quantity and solvent will be in larger quantity. But when there will be very small quantity of the solute, they are called as diluted. Diluted means more solvent, more larger amount of solvent, right? And on the other side, concentrated solution are known as the solution which has higher amount of solute. So when you mix more molecules of the solute, or when you take more amount of solute, generally it is less in the quantity, but whenever you take more amount of it, they will going to make a concentrated solution. So like you have, I guess, heard this term diluted acid, concentrated acid, you always have to use diluted acid in the labs. You cannot use concentrated acid. Why? Because in the concentrated form it has more amount of acidic substance, and it will be more hazardous for the use, right? It can cause burn, it can cause blast, or it might can catch fire. So they are very dangerous to deal with. So that's why we always going to use its diluted form. Diluted means they have more water and less acidic substance. So if when you are doing experiment with the diluted type of acid, they will be not that hazardous or dangerous, although it is going to be, but not at that extent of concentrated. In concentrated form they are more dangerous, very dangerous, but in diluted form they will be, not going to that danger. You have to be still very cautious, but not that dangerous as they are in the concentrated form. So here you can see the diagram when these are the particle of solute. So here in this solution you can see the particle of solute are very less, that's why these are known as diluted solution. And here you can see the particle of solute are very large, right? They have large number of particles, that's why we call them concentrated solution. So concentration will let you know the amount of solute present in a solution. So how are you going to calculate it? So we want to calculate it numerically, right? That what is the concentration in the form of percentage. Like in percentage, 10% concentration is there, 20% concentration is there of the solute, 30%. So we want to numerically calculate the percentage of solute present in a solution, and to do so we can do some calculation, and we can also do some numerical based on these. So concentrations and numericals. So first, how to calculate? Whenever you are going to do some mathematical calculation, you will always use some kind of formulas. So here as well, to calculate the concentration or to measure the concentration, we are going to use different type of formulas. So the first formula is mass percentage, right? Whenever you want to calculate the mass percentage. Now how to write this? It is also write as W by W percent. W representing the mass of the substance. So mass by mass, you can say mass by mass percentage or W by W percentage. So here you can write as W by W percentage. Alright. I will erase it from here. And how we are going to define it? That W by W percentage is equals to mass of the solute divided by mass of the solution, and you want to calculate the percentage, so you have to multiply it with the 100, right? So this is the formula to calculate the mass percentage. Now one more thing, how to calculate the mass of solution? If they have given the mass of solute and they have not mentioned the mass of solution, so how you are going to calculate? So you can break them down. How to break it down? Solution is a mixture of solute and solvent, right? So here what you need to do is, whenever they have not given the mass of the solution directly, you just need to do what? Mass of solute plus mass of solvent. You have to add the mass of solute with solvent, and then you will get the mass of the solution. So this is how you can break it down, right? So the first formula to calculate the concentration term or the concentration of the solution or the solute present in a solution by mass percentage. Then here you have we have written it that mass of the solution is equals to mass of solute plus mass of solvent, right? Then again next formula is mass by volume. Mass by volume, which clearly indicate that you have to divide the mass of solute by the mass volume of the solution into 100, right? So here by the help of these formulas you can calculate the percentage of the solute present in a solution. One more formula I will tell you, it is volume percentage, right? So the third formula is volume by volume. You can write it as volume by volume percentage, right? So what you need to do here, you have to just divide the volume of solute by the volume of solution, volume of solution, and into 100 because we want to calculate the percentage. So this is the third formula. If in question volumes are given for the solute and solvent, then you can directly put this formula and the values in this formula, which is defined as volume of the solute divided by volume of the solution into 100. So this is the third formula. Also, in case of volume, they might not give you the volume directly. So they will mention the density. They might will give you density. So you need to be little cautious here. Whenever the volume type of question will come, they will not give you the volume directly. That's how they will make the question little tricky. So density will be given. So what is density? Density is mass upon volume. So with the help of this, if they have given the density, if you know the mass of the solution, you can calculate the volume of the solution. So with the help of this formula, you will be able to solve the question of volume. So this is how they will make the question tricky. Otherwise, there is nothing tricky in these type of questions of concentration. Very easy concentration terms we have: mass percentage, volume percentage, mass by volume percentage. So by using only these three formula, you will be able to calculate the concentration of the solute present in a solution. All right. So let's just do the numerical, then you will understand it more. So first you see the formula, just write down the formula or note down the formulas, because when we will do the question, you have to first try and then I will make you solve the question. So by applying this very easy formula, you can solve the question. So just write down the question, note down them, and then we will solve the questions. All right. You guys might have taken screenshot as well. Okay, now let's just solve the question based on these topics. So first question on the screen is like a solution contain 40 gram of common salt in 320 gram of water, right? Calculate the concentration terms of mass percentage of the solution. Very easy question. I'm giving you, I guess, 20 seconds. In 20 seconds, you can give me the answer. I'll check your answer. Apply the formula and let me know that whether you are able to solve the question or not. Doubt for anyone, you can mention your doubt. Alright, so who will answer for this question? Very easy question. For the mass percentage, you have to calculate the mass percentage and data has been given. So to solve the question, first you need to check what is given and then see the formula and apply and put the values there in the formula. You will get your answer. All right. Okay, let's just solve. I hope you all have reached to the solution that how to calculate the concentration for these type of question. Very easy. So in the question they have mentioned that 40 gram of common salt in 320 gram of water. We can clearly see here that this is going to be the solute and this is going to be our solvent because it is present in more amount, right? So we can clearly say that this is solute and this is solvent. Water is solvent. वैसे भी water is a universal solvent, so it is going to be the solvent here. And on the basis of amount, you can also prove that. Now the amount of solute has been given, the amount of water has been given. Now they have asked you to calculate the mass percentage. So the formula for mass percentage is what? So here with the help of the mass of solute and solvent, you can calculate the mass of the solution. So by adding the values, you get 360 as the mass of the solution. Now mass percentage, the mass of the solute divided by the mass of solution into 100. You are just putting the values and here it will go 9 times 1 upon 9 and it will going to be 11.11, right? So 11.1 will be the answer for the percentage of common salt in the solution. So what is the percentage of common salt, or you can say solute in the solution, is 11.1%, right? Now let's just solve the next question. A solution contains 30 gram of sugar dissolved in 370 gram of water. Calculate the concentration of this solution. So again 30 gram of sugar dissolved in 370 gram of water. So again by seeing the amount of sugar and water, you can say that which one is solute and which one is solvent, right? So from here we have given the mass of solute 30 gram, mass of solvent is 370 gram. Also with the help of these two we can calculate the mass of the solution, which is going to be 400 gram. Now you just have to put the value, mass percentage 30 by 400. Mass of the solution is 30 and the mass of the solution is 400, and if you divide these data you will get the answer as 7.5%. So this is the final answer for this question. Very easy, right? Any problem? I don't think that in these type of question any problem will arise, because these are very direct question, very formula based question. So you will be very easily be solving these type of questions. Next question. If 110 gram of sodium chloride is present in 550 ml of solution, calculate the concentration of the solution. Now they have asked the concentration of solution. So in which term we are going to solve the concentration, because the data has been given in the form of mass and volume. So from this we will going to calculate, we will going to use the formula of mass by volume percentage. Now what data has been given? Mass of the solute sodium chloride, which is 110, mass of the volume of the solvent solution has been given as 550. Now they have directly given the volume of the solution, we need not to calculate it, or we need not to add the volume of solvent or solute, right? So it is given directly. Now you just have to put the formula of volume percentage. So how it is be, mass of the solute by the volume of the solution into 100, put the values and you will get the answer as 20%. So here the answer is 20%. Alright, very easy question again. So only these type of question will come from your concentration terms. I don't know, many students have fear or they are very scared about the concentration term, but they are the easiest type of numerical. So if you talk about the concentration term, they are easiest. But if you study them right way, if you will stick to the formula, stick to the concept, you will able to solve any kind of question from concentration terms, right? So now we are done with the numerical part. Although numericals are very, we have solved very less numerical in today's class, but in the next class I will come up with more tricky numerical, or with we'll do a lot of numerical, we'll practice the numerical. Also we will be further understanding the other categorization of your mixture, which is heterogeneous type of mixture. Alright, so stay tuned with us, keep studying hard, and also keep updating with the lectures, that when your lectures for chemistry is upcoming, when is the upcoming lecture for chemistry or the other subject. And also if your exams are near, you can mention your doubt. If you want any particular type of videos, or if you are facing problem in particular type of question, you can mention in the comment box and let us know. We'll give you a short solution. So stay tuned with us. I hope I'll see you in my next class. Till then, revise the topic and let me know and if any doubt is there. So I'll see you in my next class. Till then, bye bye. Good night, everyone.